Okay, so section 20.4, the side-side-side triangle congruence theorem. The SSS stands for side-side-side. And basically, if three sides of one triangle are congruent to the three sides of another triangle, then the triangles are congruent. So basically, let's take a look at this example, right? And these little symbols here, right? This one hash mark and one hash mark means essentially, AB is congruent to DE. And now we've got two hash marks and two hash marks. So AC is congruent to DF. And let's try a different color. And I'm just highlighting that they're there with these shapes. FE is going to be congruent, to the other thing that's got the three lines through it. That's really all that means. It's like a shortcut, so to speak, for saying all this stuff. So now let's take a look at these triangles in this example. Well, there's those symbols again, right? So we know that JK must be congruent to LK. And there are those symbols again. So we know that JM must be congruent to LM. What about KM? Right? KM. Is KM the same as KM? And the answer is, well, yes, of course it is, right? So now that we have one side congruent to one side, another side congruent to one side, and now a third side congruent to a third side. In essence, we have the side congruence theorem. So I'll give you a moment to get that written down, and then we'll move on to the next section. In this next example, I'm just going to start by labeling it. So I've got triangle MNP, and I've got triangle QRS. And I do this because, I want to know what corresponds to what. And it's just going to make my life easier if I do this. So the question is, are these two triangles congruent? Are they congruent? And we're hopefully asking this question if they're congruent by the side-side-side congruence theorem. So let's take a look. Well, the 1 and the 3 is MP. So MP is 54. Here's the 1 and the 3 for SQ, also 54. So these two things are congruent. There's one side. What about PN? PN's 38. And the thing that corresponds with PN would be SR, and those are definitely congruent, right? Two sides, two sides. So we have side, side. What about the third side? We're talking now about MN and QR. As you can see, right, these are not the same measurement. So they are not congruent. So the question is, are they congruent? No, they're not. Not by the side theorem, at least. And that's about as much as we can tell from these two shapes. So give you a moment to get caught up, and then we're going to move to the back page. So in this example, again, whenever time I see a bunch of numbers and letters and all that all over the place, I just try to take a step back and let me try to label my triangles. And then at least I can organize my thoughts. And so we've got triangle essentially D, it's like DEH. And then we have triangle FGH. And, like I said, I use numbers to help me find the corresponding parts. And then it makes everything simpler. So let's take a look at ED. ED is 20, and the thing that corresponds with ED is this section here, GF. And they're both 20, so these are congruent. So there's one side. One side's congruent to one side. And now let's take a look at DH. DH corresponds with FH. And it appears that they are both 12. So they are definitely congruent. We have our second side. That's not a 5, that's an S. Side, side. And now the last one, EH. And EH corresponds with GH. All right, we've already done this one and this one. Now I have to do the third side, EH and GH, and they both appear to be 24. They're both congruent. There's our third side. And therefore, these two triangles, I'm going to do this symbol, therefore, triangle DEH is congruent to triangle FGH. And the reason is because of the side, side, side triangle congruence theorem. Now this next example, we've got triangle ABC. And we also have triangle JKL. And I go around and I just label them with numbers. So now it's clear to see that AB corresponds with JK. and so on. So we can find basically all the corresponding parts. So we have to find the value for x for this part and that part. So if these things are in fact congruent, the sides would be the same. So 4x minus 6 would have to be the same as 3x minus 4. So from here, it's now just an algebra problem solving for x. I'm going to add 6 to both sides, and I'm going to subtract 3x. When I do that, that cancels. I'm going to get x. 4 minus 3 is 1. When I do this, this cancels. 6 minus 4 is 2. So x must be 2. And if I want to test it out, 4 times 2 minus 6, is that the same as 3 times 2 minus 4? We got 8 minus 6 is 2, yep. 6 minus 4 is 2, yep. Both true. So I've tested my answer as well. And I think we're going to skip the last example, and we'll just go right into the homework.